Hello, Trig. 9.3 is based to some degree off of 9.2. We won't have any modes or any medians appear today, but the mean is still super important today. I'm working from a 9.3 notes paper in my own writing, and then we have the spreadsheet from yesterday. We're going to add on some columns and just keep on going with it. So the words of the day today are deviation. Deviation is just the difference from the mean. Difference always means subtract. So we'll have to figure out the mean like we did yesterday, the average, add them up, divide by how many there are, and then subtract that mean to find a thing called a deviation. The deviation can be used to figure out a thing called the variance. The variance is the average of the squares of the deviations. And we can use the variance to feed into a thing called the standard deviation, which uses a Greek letter as its abbreviation in the notes there. The standard deviation is the square root of the variance. You have to be careful when you do these, because since one answer leads to the next, if you miss one of them, the rest go down to twos. So your standard deviation can only be right if you have a right variance. The variance can only be right if you do the deviations right. The deviations can only be right if you do the mean right, so I hope you're having success at doing the means, and be careful about those. So here's a smaller problem to begin with, and then we'll finish the one we had yesterday with the table, which was a larger problem. But if they give you a small list of numbers, start off finding the mean. The mean is the cornerstone to this whole event. So to do the mean of these 5 numbers, we would add those up to be 413. We would divide by 5 because there are 5 of them. And if you divide, we would get a mean of 82.6. If you don't get the mean right, you're done. To do deviations, we will now take each of these numbers and we'll subtract the mean to figure out how far away we are. If 76 subtracts this, that comes back a negative 4.6. I didn't put a negative on my paper. I probably should have. It doesn't really matter though, because the next step we're going to square them. And squaring is going to make positive, so that's not a crucial detail. 83 subtracting this is a 0.4. 96 subtracts the mean, that's 13.4. 75 subtracts the mean, that's negative 7.6. 81 subtracts the mean, that's negative 1.6. And those are our deviations. To build the deviations up into the variance, we're going to need to take those deviations and square them. So a 4.6 squared, 0.4 squared, a 13.4 squared, a 7.6 squared, and a 1.56 squared. What we need is the average of those squares, which means these have to get added to 261.20, and then divide by 5 because there are 5 of them. And that's going to show you a 52.24. That would be the variance. The standard deviation is the square root of that number. The standard deviation is then going to turn up to be a 7.228. In terms of meaning to life, the standard deviation is like a measurement of kind of like how closely packed the grades are. So like the calculus class, the grades there would not have a very big standard deviation, because I have a 97 person and I have a 96 person. Not a lot of difference there. Everybody's pretty close to the mean, they're all close to each other. That would have a very low standard deviation. The trig grades, when we left off, ranged anywhere from 39 to 91, because we had people missing tests and the grades were all screwy. So a group like that, where the grades range anywhere from 39 to 91, that would have a much larger standard deviation, because they're just, the grades are just spread. 7th grade math is like that, from 37 to 96. The grades are spread all over the place, so that would have a large standard deviation. Chem, not as big, bigger than Calc. They're anywhere from 66 to 98. They're still spread, sort of like a medium standard deviation. Back to this example, just building off a bit to speed up some time. The homework questions, you might need to still do this whole thing from scratch, where you're doing the multiplication to count up how many of an item you had, to do the mean. What we had yesterday, we knew the mean yesterday was 4.9. But you might have to repeat this process on the homework problems just to get to figure out the mean. And then we would need a deviation column. When you have a table, it's a little bit trickier to make sure you grab the right numbers to subtract with. Okay, here we had an 82. The 82 was a result of these, so we subtracted these with the 82. Okay, what caused our 4.9 was these. 1, 2, 3, up to 10, those were the types of trees we had, from 1 to 10, averaged out to be a 4.9. We're going to need to do the 4.9 subtracting our 1 through 10 kind of numbers. So 4.9 subtracting 1, 2, 3, 8, 4, 5, 6, 7, 8, 9, and 10. So we have that column of deviation. These would technically be negative. If you forget to write the negatives, life can go on. We then need to do deviations squared. So I need to do 3.9 squared, 2.9 squared, 1.9, 0.9, the 1, 11, 1, 1, 601. When we did the other problem, here we had the deviations squared and we added those up. Over here, we can't just take the deviations squared and add them all up. That would only be true if there was one of each number. That first simple list I did, there was one of each number in that list. What we have to take into account is that these deviations, sometimes there's none of them, sometimes there's one of them, sometimes there were 12 of them. We need to do the deviation squared times the frequencies. We need this 15.21 to get counted twice. We need 3 of this number. We need 3.61 to be counted 6 times because it's there 6 times in the list. 3 separated from 4.9 is 1.9 away. But for us to have an accurate list and computation on this, we have to take into account there were 6 of those 3s. There weren't just one of those. So I need to take this column times this column to feed into the next column up. So what I'm showing here on my paper is a 30.42, 25.23, 21.66, 891, 08.01 times the 8, that's what we're doing here, 14.52, 22.05, our good friend the 0, because anything times our 0 is going to work out real well. We have 2 times this, it's 33.62, 1 of that last one. These are what we need to add up, and that gets 182.50. 182.50 has to divide by 50 because we're after the average of these numbers, and there's 50 of these numbers, and that would show up a 3.65. 3.65 is the variance. And then to do the standard deviation, we just root that, and it's 1.91. It's not a very big number because, again, our list only went from 1 to 10. So how packed are they? Well, from 1 to 10, there's not much of a variation there. But the standard deviation there is 1.91. Homework on this, we're up a page 280, and I don't have the assignment in front of me, but like the little syllabus grid paper, it knows everything. See ya.